athletes. Today we're going to look at something called the golden ratio, and we're also going to look at the Fibonacci numbers. So, have you ever taken a selfie and thought, wow, that looks good, but you're not sure why? Well, it might have something to do with math and something called the golden ratio. Faces that are considered balanced or beautiful often follow the golden ratio or something close to it. Here's how. Let's measure from the top of your head to your chin. If you want to try this, you can go grab a measuring tape. But I did it, and what I came up with was 16 centimeters. Then I measured from my forehead to the bottom of my nose, and I ended up with 10 centimeters. Now I'm going to find the quotient of them. So I divided the total height by the nose height, and I ended up with 1.6. Well, if you get close to 1.618, you've got some golden ratio action going on. So apparently I do. You might want to pause the video here and give it a try on your own. So the golden ratio is approximately 1.618. More precisely, it's what we call an irrational number, which means it goes on forever without repeating. You might have heard of pi. That's another example with the 3.14. So if you wanted to figure out what the golden ratio is, you would add 1 plus the square root of square root of 5. And then for that quantity, you divide it by 2. And you would end up with 1.61803398887, going on and on and on, again, without any repeating. So where do we see this number? Well, we can see it in nature. It's the way sunflower seeds are arranged or how a seashell spirals. Also in design, it helps to make buildings, logos, and even phone screens look just right for our eyes. We use it in art. Leonardo da Vinci used it in his paintings to make them even more beautiful. So why do people care? Well, because things that follow the golden ratio often look more balanced or pleasing to us, even if we don't know why. It's like a secret code for beauty in the world. So let's investigate this golden ratio. You can see that I have 3 rectangles with a length and a width. So what we're going to do is we're going to write the ratio of the length to the width. And the length is always going to be the longer of the 2 sides. So in the first one, it's a square, so the ratio is 3 to 3. And I divide 3 divided by 3, and my decimal is 1. For the next one, the ratio is 6 to 3, and I divide 6 divided by 3, which is 2. And the last one, the ratio is 5 to 3, and I divide 5 divided by 3, and I end up with 1.6 repeating. So which rectangle do you prefer? Well, if you were going to design a TV screen, a phone, or a swimming pool, would one shape be more pleasing to the eye than others? What do you think? Well, let's build an approximation of the golden rectangle. Now remember that the golden ratio is approximately 1.618. So we're going to start with a square that's a 1 by 1. Now we're going to write a ratio of the sides. 1 by 1. The decimal is going to then be 1. Now we're going to add another 1 by 1 square. So now I have a 2 by 1. 2 divided by 1 is 2. Now I'm going to add a 2 by 2 square to it. That's that blue one. And now it's going to be the ratio of 3 to 2. I divide 3 divided by 2 and I get 1.5. Now we're going to add a 3 by 3 square to the right of it. That's my pink one. The ratio of the sides, the long side is going to be 5 and the short side is 3, so 5 to 3. And the decimal is going to be 1.6 repeating, just like the one on the previous screen. Now I'm going to add a 5 by 5 square. That's that turquoise one. And the ratio of the sides is 8 to 5. So the decimal is 8 divided by 5, which is 1.6. So what do you see? What do you think? And what do you wonder? I suggest you pause the video here so that you can look at these and see if you see any patterns. Okay, so here's what we came up with from the previous screen with our ratios and our decimals. Now let's see if we can follow a pattern to figure out what the next 3 rectangles would look like without having to draw them. So I notice that it's 1 to 1, 2 to 1, 3 to 2, 5 to 3, and 8 to 5. So my next ratio is going to be 13 to 8. Do you see how I'm getting this? If not, keep with me. Maybe you'll be able to figure this out. And 13 divided by 8 is 1.625. The next ratio, 21 to 13. And it's about 1.615. And the last one is 34 to 21, and it's about 1.619. Again, you might want to pause the video here and see if you can figure out the pattern. Did you find the pattern with the ratios? Well, here's what I noticed. I noticed that the length of the rectangle is the sum of the length and width of the previous rectangle. I noticed that the width of the rectangle is the length of the previous rectangle. So for example, for that first one, if I add my 3 and my 2, I end up with the new length, which is a 5. I add the 5 and the 3, I end up with the 8. Those are my lengths. For the width, it's the length of the previous one. So this one is 5. So for this one, it's going to be 3. Did you find a pattern with the decimals? Well, I noticed that as the numbers of the length and the width increased, the decimal became closer to the golden ratio. Look at how close that is to 1.618. It's only off by 1/1000. Well, the sums for finding the length of the next rectangle use something called the Fibonacci numbers. And they are a special sequence of numbers, and they go something like this. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and they go on forever and ever. They're infinite. So here's how it works. We start with 0 and 1, and then we add the last 2 numbers to get the next one. So here's how it builds. I have 0 plus 1 is 1. And then I add these 2 ones, and I get 2. And then I add the 1 and the 2 to get the 3. And I add the 2 and the 3 to get the 5. I add the 3 and the 5 to get the 8. I add the 5 and the 8 to get 13, the 8 and the 13 to get 21, and so on. Does it see? See how it's growing? Think of it like a math growing pattern. Every number is the sum of the 2 before it. Now, if you take any 2 Fibonacci numbers in a row and divide the bigger one by the smaller one, you start to get closer and closer to the golden ratio, again, about 1.618. So let's look at this one. 2 divided by 1 is 2. 3 divided by 2 is 1.5. 5 divided by 3 is about 1.6 repeating. 8 divided by 5 is 1.6. 13 divided by 8 is about 1.625. 21 divided by 13 is about 1.615. And 34 divided by 21 is about 1.619. Again, 1/1000th away from the golden ratio. So the bigger the numbers, the closer you get to 1.618, which is the golden ratio. So these are spirals that are common in our natural world. You can see these spirals in our shells, pineapples, sunflowers, even pine cones. So now let's use these patterns to create a spiral. First, you need a piece of grid paper. Now, the directions are going to look a little confusing, so I'll read through them with you. Then I'll make the spiral, and then if you want, you can go back to the video and then make it. Once you see me making it, it'll make more sense. But here are the directions. You're going to make a square in the middle of your paper. Actually, I suggest you make it up a little bit higher. Make an arch from the lower left corner to the upper right corner. Then you're going to add a 1 by 1 square to the right of the first square. Now complete the arch from the upper left-hand corner to the lower right-hand corner. Always work clockwise. So now you're going to add a 2 by 2 square to the bottom and continue that arch to the lower left-hand corner. Then add a 3 by 3 square to the left and continue the arch. Then add a 5 by 5 square to the top and continue the arch. And lastly, you're going to add an 8 by 8 square to the right and continue the arch. So here's how it should look. Here's my square, and I'm going to draw that arch from the lower left-hand corner to the upper right-hand corner. Now I'm going to put a 1 by 1 next to it, and I'm going to continue that arch with the upper left-hand corner to the lower right-hand corner. Now I'm going to do my 2 by 2, and again, continue the arch. Doing my 3 by 3, continue the arch. My 5 by 5, continuing the arch. 8 by 8, continue the arch. And actually, because I moved my square up a little bit, I could put a 13 by 13 on. So do you see a pattern? And what is it? Well, it should look like those spirals that we saw previously, like the one in the shell. Nature learned how to make this spiral long before you did. But the golden ratio doesn't just appear in nature. Throughout history, the ratio for length to width of rectangles of 1.618 has been considered the most pleasing to the eye. This ratio was named the golden ratio by the Greeks. In the world of mathematics, the numerical value is called phi, named for the Greek sculptor Phidias. The space between the columns form golden rectangles. Now, recently, some people were saying that actually it doesn't. If you figure out the ratio, it's actually 1.7, but it's pretty close. There are also some golden rectangles throughout the floor plan of the Parthenon, which is in Athens, Greece. You might want to pause the video here and look at some of these and see how many you can find. Many artists who lived after Phidias had used this proportion. Leonardo da Vinci called it the divine proportion and featured it in many of his paintings. One is his famous Mona Lisa. And you can see I drew on there the spiral so that you can see how I'm using the golden ratio and also the Fibonacci numbers. Her measurements are in a golden proportion. He did an entire exploration of the human body and the ratios of the lengths of various body parts. Other body ratios that sometimes have the golden ratio are the width of the mouth versus the width of the nose, the distance between the eyes versus the width of the head, the eye to the chin versus the forehead to the chin, and the total height to the height from your navel to your feet. You might want to pause the video here and try these on yourself. So why does this matter? Well, the golden ratio and Fibonacci numbers show us that math is in nature, design, art, and even the human body. They're not just numbers. They help explain why things look balanced and natural. So as you go out into the world, I want you to see how much you notice now where this golden ratio is, where you can see it in nature and in art and design. It's everywhere and all around us. As always, thank you so much for watching.